Hello everyone, I'm Adarsh Shukla. I'm currently a third-year undergraduate at IIT Roorkee, currently in the engineering physics branch. And in this video, I'm going to go through my presentation on software-defined radio for PHN 313. In this video, I'm going to go through all the contents here, starting with evolution of signal-defined radio. So, in the old times when there was a need of transmission of signal from one place to another place, there was some problem faced by traditional radios, which faced compatibility issues due to restricted frequency ranges. And especially in wartime, when there was a need of communication, they faced frequency ranges issues. So there was a need of some technology which can benefit as in it can be used for wide range of frequencies. Then there comes SDR technology. SDR technology was introduced by J. Mitula in 1991 and has significantly evolved since then. And as time passed, there was some advancements with SDR. There was software integration, which basically uh, helped as software programmable radios that can operate on multiple frequencies and standards. And in nowadays, there is an adoption of USRP platforms, uh, which uh, uh, which creates flexible high-performance SDR systems. So basically, what is software-defined radio? SDR is a communication system where hardware functions like filters, modulators are handled by software. So basically, in SDR, there is a software integration which basically controls the hardware part and which enables the dynamic switching between frequencies and modulation schemes for enhanced adaptability. And there is a software control, which is the most accessible part and useful. And SDR form describes for providing software control over modulation techniques and waveforms. And there is a benefit of broad frequency ranges. As it supports a wide frequency range, it accommodates various communication needs. So what are the key components of SDR? Key component of SDR includes the antenna, a smart antenna, which captures radio frequency signals from the environment and transmits processed signals. And it has a role of interface between the SDR hardware and wireless medium. It basically takes the input and transmit the signal and receive the signal and transmit the output. It has work of that. And then there is a frequency front end and digital front end. So radio frequency front end section has a function of that converts signals between radio frequency and intermediate frequency. And it has some hardware functions like amplifiers, filters, shifts the frequency of the signal for easier digital processing. And after that, there is a analog to digital converter and digital to analog converter. For analog to digital converter is used to convert analog intermediate frequency signal into digital form. And it has a role of preparing incoming analog signals for digital processing in the SDR. And then there is a digital to analog converter. So digital to analog converter, as you can see here, digital to analog converter, when we give the input signal, it basically for processing the signal. And then there is a digital front end. So digital front end functions as it adjusts the sampling rate and extracts desired frequency channels. So it has a role of optimizing signals for further processing. Like for software part, we need digital processing of the signal. So it basically channelizes and uses sample rate conversion of the signal. And then there is a baseband processing unit or DSP unit, digital processing unit. So which has a hardware components like FPGAs, DSPs, ASICs, GPUs, GPPs. So FPGAs, SICs are the hardware units, which means FPGA means field programmable gate array, which is used for flexible hardware devices that can be programmed on to perform specific tasks for processing function. Then there is a DSP, digital signal processor, which are specialized microprocessor optimized for high-speed mathematical operation. Then there is ASICs, application specific integrated circuit, which are custom designed chips built to perform a specific task very efficiently. And then there is a GPU, processing unit, which is basically used for our convenience, designed to handle parallel processing tasks and are originally intended for rendering graphics. And then there is a GPP, general purpose processor, which is used for in computers and other electronic devices that can be handle a wide range of tasks. For handling wide range of tasks, use that. And then we can see in the next diagram, there is an analog end and digital front end. Analog end, as I have told, which converts the digital to analog for transmission, and analog to digital for receiving end. For transmission, we can see after converting from digital to analog, we use filter and amplifier for filtering unwanted signals and amplifying it for transmission. And then there is a mixer and then amplifier, and then it goes to the smart antenna to transmit it into wireless medium. And in the receiving side, all the functions are same with reversed order, but the only difference is that LNA. LNA means low noise amplifier, which basically removes all the noise and de-amplify the signal into a lesser amplified signal. And then there is a distal front end. Distal front end basically channelizes and sample rate conversion of the signal, which contains distal baseband signal processing block, which samples the signal. And then there is an interpolation filter, which filters out all the unwanted signals and converts it into digitized manner. So in the digital front end transmitter, we basically convert digital baseband samples into digital intermediate frequency samples. But similar to the opposite to that, in digital front-end receiver, we basically convert intermediate frequency signals into baseband signals. For basically for transmitting, we use digital to analog converter, and for receiving, we use analog to digital converter processing the signal. And this is the complete diagram for SDR transceiver for transmission and receiving end. For transmission end, you can see. We take the input for transmission. This is the transmission end, and then there is a receiving end. So for transmission, we basically first do the baseband processing through software and then through hardware. So software part contains algorithm, middleware, Cobra, and these are some software applications. And then there is a hardware application, as I've told you earlier, FPGA, DSPs, ASICs, GPUs, and GPPs. These do hardware processing, and then it goes into the digital front end for transmission, and in digital front end, it does channelization and sample rate conversion. Then it does digital to analog converter. Then RF front end, which basically does all the hardware part, amplifier, amplifying, filtering, all the part uh, does by RF front end. Then it transmitted through a smart antenna. And for receiving end, wireless signals come from another place on the smart antenna, and then it goes for RF front end. It filters, amplifies, and uses LNA, and then it goes to analog to digital converter. We basically for receiving end we use analog to digital converter. Then there is a channelization and sample rate conversion as same, and then it goes for baseband processing. For baseband processing, we use only digitized signal, not analog signal. So this is the working principle of SDR transceiver. And now we are gonna go through the benefits of SDR. So SDR provides flexibility as it channelizes and modulates the signal and can be changed via software without hardware modification. It has a benefit of interoperability, which facilitates seamless communication across various wireless standards. And it is also multifunctional, which supports the multiple standards like Bluetooth, WLAN, GPS, and it has a frequency reuse function. Means we can reuse the frequency which was once used, and which employs cognitive radio to detect and utilize underused spectrum efficiently. And it has a ease of upgrades because software updates are very easy and very cost efficient, as we don't need to update any hardwares. So it has a functionality which has a need for which doesn't need the hardware changes. Now, what are the possible challenges for SDR? The possible challenges are security issues, deployment complexity and cost issues, and high-speed DEC to ADC requirement. Security issues, as in there is a software integration. So in software integration, there are risk from malicious software, which predicts measures like digital signature and trusted computing. And there's the issue of deployment and complexity and cost, as there is a need of large towers to build, and platforms like USRP are very expensive. So we need uh, it is very cost effective, and there is a need of high speed DC to ADC component, as for transmitting and receiving we need analog to digital converter and digital to analog converter. And what are the possible solutions for these challenges? Possible solution, as in for security solution, we can implement digital signature and security administrative module to ensure the integrity of software used in SDR system. And there is a complexity reduction also. Uh, we can utilize the open source hardware programs like GNU Radio to facilitate cost-effective experimentation and development. Also, power consumption management is also a solution. We can adopt cooperative wireless networks, and means other companies' wireless system that has already been established. We can use that as a resource sharing techniques to manage and reduce overall power consumption of SDR operation. And antenna design optimization. And, we can incorporate advanced designs like MIMO tunable antennas to achieve broader frequency ranges and improved performance. Now, we are gonna go through the conclusion. So basically, SDR enhances communication system. As in the old times, we had a problem with the frequency ranges. SDR solves that problem, and there are a lot of advancements in technology. And what are the future directions in the SDR? So SDR, we can use it as an enhanced security protocols, which focus on developing robust security measures to protect SDR system. And there is a improved hardware design, integration with IoT, research and collaboration, tackling existing challenges and advanced applications like exploration of new application for SDR in diverse field. Now, as for reference purposes, I used ResearchKit for software-defined radio operation challenges and possible solutions by Devaprita Sinha, Anish Verma, and Sanjay Kumar. And I also preferred the ATES research website for USRP, Universal Software Radio Peripheral. And thank you, everyone. This was an overview of software-defined radio.